saying that 3 to the power of 7 is the number of maps from, was it a 3-element set? 7-element set.
Seven element to a set. From a set of 7 elements to a set of 3 elements.
Yeah. So I guess if you want to make it concrete, you could just make it the numbers like 1, 2, 3, 4, 5, 6, 7, right? It's a 7-element set.
Yep.
2, and it's a 3-element set, right? So X, Y, Z. So it's like, oh, maybe if to be more friendly, A, B, and C. Okay. So what exactly is a map? Well, it's a function, right? And a function, so this is meant to be the domain. And this is meant to be the codomain. Right? So what does it mean to be a function? It means everything in the domain has to be accounted for. So we have to know how to do something with every one of these numbers.
Yeah.
So if I put 1 in, okay, I'd have to know what happens to 1.
Yeah.
Yeah. So it could go to A, B, or C. Okay.
Did this have something about onto?
Yeah. The last part was
Yeah.
show how many of them are onto.
Onto just means that every domain has a codomain, right? Is that onto, or is that?
Sort of. So it's every element in the codomain has something coming from it.
Ah, okay.
From the domain getting there.
Yeah.
So yeah, like what does it mean to be a function? 1 has to go somewhere, 2 has to go somewhere. Everything in the domain has to go somewhere, right?
Yeah, but onto is when the codomain.
Yeah, and
every
then
codomain has a domain.
Yeah, exactly. So in principle, all of these 7 things could just go to A.
Yeah.
Right, and then that would not be onto because B has nothing going to it. Yeah, and it's important that like whatever you send 1 the first time, if you put 1 in again, it should get you the same answer. It's deterministic. Yeah. So can you see the number of functions is just the number of ways of choosing a value for each of the 7 numbers. So you can choose A, B, or C for 1. You can choose A, B, or C for 2, right? You can choose A, B, or C for each of those 7 things.
Yep.
So the total number of functions will be 3 times 3 times 3.
Yeah, all the way down.
All the way down to here. So that's 3 to the power of 7, right?
Is that what I'm meant to be doing?
Well, I'm just explaining the first part. Yeah.
Yeah.
But so then the question is, show that 1806 of these. So this number, it says how many is it? It's 2000 and something.
2187.
2187. And,
yeah.
and then it says 1806 of these are onto. Okay.
Yeah, I don't have the slightest of a clue how to do that.
Yeah, so clearly, clearly the function that sends everything to A is not onto, right? If it sends everything to B, it's not onto.
Yeah.
So we need to basically pick something for A, B, and C, right? So can you see that one way of doing it is to sort of figure out what goes to A. So one of the things about counting is you have to be systematic, or you kind of miss stuff, you know. And if it's like you have to get it to within 1, right? You have to be pretty systematic.
Yep.
So you have to come up with a system. There's not necessarily just one way of doing it. You have to come up with some systematic way of doing it.
Yeah.
Right. So for example, I don't know. A natural thing to do is to make use of the stuff we just learned, the combinatorics, right?
Yeah.
The choosing stuff. So since we did that, that's the thing I'll think of first. You know, if I was doing some other topic, I might think of the other thing first. But with the combinations, I might think, well, let's pick things to go to A, B, and C, right? So we could be a bit systematic about this because we could say like, first, how many things go to A, how many things go to B, how many things go to C. Those numbers can't the different numbers for those will give you different functions, right? And as long as the numbers are not 0, it's onto, right? As long as something goes to each one of them, it's onto.
Okay.
So for example, I could have like, out of the 7 things, I can't have 6 of them going to, I can't have 6 of them going to A, right?
Yeah, because that's not onto.
It's not onto. I can have at most 5.
Yeah.
So I can have 5 going to A. So that's A, B, C, right? I can have 5 going to A, 1 going to B, 1 going to C.
Yep.
Yeah. And that's the only one you can do with 5. Or you could do like, permutations of this one. Or you can have, right? Okay. Or you could have, for example, 4 going to A.
Yep.
And then you could have 2 going to B. And then it has to be 1 going to C. And then you could have 1 and 2, right? And then you can have permutations of this.
Yep.
So there's another 3 ways. It looks like it'll take forever, but I think once you get to 3, you kind of start running out of options pretty quick.
So that's actually how you meant to answer the question. Just
Well, I mean, the context. It's a tutorial, right?
Yeah.
So like the tutorial, you're kind of meant to discover it a bit more.
okay.
I mean, in an exam, you might I don't know. There might be like a formula you might just be able to apply or something. Actually, it's a I don't know how famous it is, but it's actually not. There's no formula for counting the number of onto functions. It's kind of a funny thing. Like there's a formula for counting the number of 1-to-1 functions from a 7-element set to a 3-element. There's no formula for counting the number of onto. But the numbers are so small we can actually just count them.
Yeah.
That's kind of the point of this question, I guess.
I guess I'll just.
Yeah, so we can reorder these. Yeah, I think it's good to get into this kind of thinking because there will be some problems that you kind of feel a bit not familiar with, but like they're actually kind of easy because you have the principles.
Yeah. Wait, so what am I proving by just listing
okay.
these?
So I guess I'm kind of breaking it up, sort of in a way that makes it easy to count. So if we kind of list all the possible sizes of things that go to A, B, and C, right? Let's work if we just fix this size, right? It's like how many ways can I have 5 things, 1 thing, and 1 thing? How many ways can I do that, for example, right? Like how many ways can I have 5, 1, and 1?
Yeah, it was.
So, well, basically, I'm picking 5 things to send to A, right?
Yep.
And the order matters because it matters which one you send. Well, it actually does. The order doesn't matter because you're sending them all to A, right?
Yep.
So they'll be the same function as long as they all go to A, and then you're picking one of the last 2 things to go to B, and the last thing has to go to C, right? So, so the number of ways of doing that is 7 choose 5, right? Times 2.
Yep.
Or you can view it another way. Well, you can view it as picking B and C first, for example. If you pick the thing that has to go to B, there's 7 ways to pick that. And then there's 6 ways to pick the thing that goes to C. And then there's no choices for what goes to A because everything else has to go to A.
Yep.
So in one way, it's 7 times 6, right? That's one way of saying that, right? Another way of saying that is 7 choose 5 times 2. Okay, because that's how many ways you can pick the 5 things going to A first. And then once you pick 5, there's 2 left over.
Yep. Okay.
and one of them goes to B. So you pick. There's two ways of picking that one thing.
Yeah.
So it might be a nice exercise to actually show that these two numbers are the same, just to sort of grind in what you had for the first question.
42 and. Oh yeah.
Yeah, they're the same, right?
Yeah.
So can you see it like the way we showed you? So like remember how 7 choose 5 is the same as picking. It's the same as 7 choose 2, right?
Yeah.
And then 7 choose 2. Well, that's 7 times 6 divided by 2 times 1. And then if you times by the 2, it'll just be 7 times 6.
Yep.
Okay.
Yep.
Yeah, so I think with the tutorials especially, it's good to try to like, it's kind of just to appreciate that you can get the answer somehow. Whereas in the exam preparation, you're more worried about like efficiency and the time limit and stuff.
Yeah.
Because like there was a time when people didn't know the answer to these problems,
Mm.
like at all.
So how do I set out the actual answer for this question? Because surely this doesn't prove that 1, 8, or 6 are onto.
Yeah, actually, there's another thing that might help because So if you were gonna go through it this way, right?
Yeah,
So-
I think I'm done. Wait. I don't see.
Like, could you see at least how you would finish this in principle?
Yeah.
So you would have this. There's 42 ways of doing that, right?
Yep.
And then you times it by 3, right? Because there's 3, ways of arranging
Oh.
like that, right? And then you'd figure out how many ways of it to do this, and then you would times it by the 3 permutations as well. And then once you get down to sort of 3, you can have 3.
3, 3, 1, 3, 1, 3, 1, 3, 3.
Yeah, so
I think that's it.
3, 2.
Oh right, yeah. What am I thinking?
So there's not too many combinations, but in principle, you can get one of these numbers for each one of those, and you add them up.
Yeah.
Right. But if you kind of look at it, they tell you what the number should be, right? And it might actually suggest another way of doing it. So, for example, like 1800 is a big fraction of 2100. It's almost all of it, right? So it might be simpler to count the functions that are not onto first, and then subtract them from the total number.
Mm.
See, that might work also.
Yeah.
You see what I'm saying?
Yeah. Kinda.
So, for example, how would you count the ones that are not onto?
You just do the same thing pretty much, but like.
Well, it'd be much easier because you're meant to get a much smaller number, right?
Yeah.
So actually, that's probably what you're meant to do, but you'd only be able to discover that and experience it being easier if you kind of work through it.
Yeah.
You know what I mean? So if they're not onto, so one way they're not onto is that they all go to A, right?
All go to 1, yeah.
So if they all go to A, there's only one function that does that, right? If they all go to B, there's only one function that does that.
Yeah.
There's only 3 functions that all go to one thing.
Yeah. So is that 42 of each? Because.
Oh no, because there's no way to choose any of them. So
Oh yeah, true.
they have to all.
That's a good
Yeah,
point.
that goes to A. That goes to A. You know what
So
I mean?
they're literally just one.
Yeah. So basically, what this means is there's 3 functions or 3 maps
Of the leftover.
with
However many 300.
element range, right?
381.
Okay. And then, well, that's very promising a start because to get the things that are not onto, they can only have 1 element range or 2 element range, right? So then the range could be. So the range could be A and B, right? It could be B and C. It can be A and C. There's only 3 possibilities because there's only 3 ways to leave out one of them.
Yep.
Okay. And then, so if that's the case, then you're basically trying to pick. It's slightly easier because you only have to do 2 numbers now.
Yep.
Even though the third number is kind of. So you need 2 numbers that add up to 7.
Yep.
Right. And I guess these are all going to be different functions, the ones in these class. So you can just actually figure out this one and times it by 3.
Yeah.
Right?
Okay. I'm gonna. So I've already done 7-0, so 6-1,
Yeah, 6, 1,
5-2,
5, 2,
4-3.
4, 3.
That's it.
Yep, and then the flips, right?
Oh, oh yeah, you can do the flips actually.
Yep.
Yeah, I was thinking couldn't. 1, 6.
Let's see if that works. Yeah, so to pick one thing out of 7, there's just 7 ways, right?
Yep.
And then to pick 2 things out of 7. How many ways did I pick 2 things out of 7?
Right, so it's
21.
wait, so 7. Choose
2.
2 times 5, or just.
Oh no, because
is it
once you
just
pick the
7
2,
choose?
the other 5 is fixed. You don't have a choice anymore. Because once you pick 2 to go to B, the others all have to go to A.
Yeah, okay, I get that. Yeah, it's 21.
21, yeah. And then how many ways are there of picking 3 things from 7?
Oh my god, actually, I just don't know. So
35.
35.
So hopefully that works. I mean, if you add these up,
Right, and then it's just 35, 21, 7.
yeah, so what's 35 plus 21 plus 7?
And is it times by 2 because you got the.
Times by 2 because
Yeah.
you've got to have it the other way as well.
Yeah. 126.
Okay, then times it by 3
And then add 3 for the.
for these ones. So times
Yeah.
it by 3.
So that's. Why no? Should have just written down the answer. Yeah, so it's 126.
So 126 is this times by 2, right?
Yep.
And then times by 3 for all that.
378.
378, good. And then add 3.
So then you have 381. And you just proved that 2187 minus 1806 is 301. 381.
And is it?
Yeah.
Isn't that nice?